Hey everybody and welcome to AV Cyberactive. In this module, we are talking about mitigating techniques to secure the enterprise. Let's go ahead and take a look at what we'll cover today in this module. We'll be talking about segmentation, access control, application allow listing, isolation, patching, encryption, monitoring, and concepts of least privilege, configuration enforcement, and hardening techniques as well. And as usual, a little more detail into the subtopics we'll be covering in this module. You can go ahead, pause here, review at your own leisure, and then when you're ready, let's go ahead and get started. Okay, now we talk about segmentation. There are several methods. Basically, we want to separate one thing from the another, and we can do that at the physical or logical layer. Physical host or a network, or we can also logically create separate networks or virtual local area networks. And then virtualization. We'll talk more about that in more detail in just a moment now. And then we also have air gap or a network that is completely disconnected from other networks, from the internet and so forth. So if we talk about physical and logical, so we see here that we have a physical network right here, and we have a number of hosts denoted by the circles here. So we have hosts that are connected to a network. So as you can see here, they are physically connected and they are all connected to the same switch. However, you can also logically separate these hosts. So even though they are physically all connected together, we can create logical separate networks. So in this instance, we have VLAN 10, and when we create virtual local area network, we can call it whatever we like. I like to talk more about that in just a moment, but in this example, we have VLAN 10, we have VLAN 20, and then 30. So basically, we are taking all of these physical hosts. They are on one physical network and then creating three logical networks. So to put this in a different way, here we have a multi-floor building, and you can see the red line here denotes the network itself, the physical connectivity on the floor and also between floors. So on floor 1, we have a switch, which is the blue box here, and then several PCs connected. On floor 2, a switch as well, along with several PCs. And then as you guessed it, on floor 3, there's another switch and additional computers on additional PCs. But what we can do here is actually create a virtual network. So VLANs that will span these networks across floors. So in instance, we have VLAN 10, 20, and 30. VLAN themselves can group hosts that are in different locations into logical grouping to put them in the same logical network. So what it basically does is create smaller collisions domain, reducing the chatter. So you may think of this as if you walked into a cafeteria, for example, a lot of people are talking. It's hard to understand because everyone's chattering or talking over each other. Well, if we take that same group of people, put a third of them in a room, a third in another room, and then the remaining third in the third room, well, guess what? The chatter is reduced because we have less people in that room. That's basically what we are doing here. We're taking all the computers that are physically attached on the network and we are separating them into logical networks. And we may do that between floors because let's say, for instance, we have some HR folks on floor 1, 2, and 3, or some perhaps in the graphics department or finance, so on and so forth. Well, even though they are sitting in different areas, we can group them together so they are on the same network. That way, their communication is segmented between themselves. Basically, what it does is it creates a security boundary to segment traffic. So these users really only talk to each other. It doesn't leave the network unless it's routed across a network. VLANs do have the ability to create that security boundary and also a collision domain so that broadcasts don't pass between those networks or separate networks. So ultimately, it makes things more efficient and makes things more secure. Next, we have the concept of virtualization, and virtualization is the method of segmentation or isolating. So, what we are doing is keeping a host in a sandboxed or an isolated environment. So, it allows for snapshots, allows us to quickly revert changes, that also separates guests from the host hypervisor. We'll talk more about virtual machines and the whole process of virtualization in different module, but for now, in the context of the security, understand that by sandboxing, we are basically putting a PC or an application into a sandboxed environment. We can put guardrails around that so it cannot talk to other things. It cannot talk to other hosts, and it also cannot talk to other computers on the network. Potentially, again, it depends upon how things were set up, but allows us to test things or even allow malware to run as an example. And we can watch it in a controlled environment to see what it does. And then other devices can be virtualized as well. So infrastructure such as routers, switches, load balancers, firewalls, and so forth, all of these things have their own virtual counterparts as well. And when we virtualize things, again, we have the ability to upgrade them, patch them, load balance between them much more efficiently than we would be doing if we had to physically rack the stack somewhere else in the infrastructure. And then we have the concept of air gap. So an air gap is the method of isolating a computer or a network from internet and also from external networks. And these things are typically done or typically seen in the instances where you have critical infrastructure like SCADA systems where they operate critical infrastructure, nuclear facilities, and so forth, and also highly secure classified networks as well. So some advanced techniques can actually jump air gap networks, and these things have been demonstrated. But obviously, it's not very easy. But it is possible in very specific situations, and we are talking about things like emanations and FM frequencies where you could literally watch the lights blinking on the hard drive from across the room, and you could potentially read them like what's being written into the hard drive. But then again, it's pretty much a corner case, not something you would typically see. But just to be aware, in extreme examples, air gap networks does not necessarily mean 100% secure. Next, let's talk about the concept of access control list or ACLs. And what we are doing here is determining the level of access to one or more resources. Basically, we are talking about permissions, so read, write, modify, delete, those type of things, execute as well, depending upon which operating system you're in, but the permissions that are needed to a specific action. Then we also have no access, which basically means if that's turned on, it doesn't matter what the permissions you have. If no access is enabled, that basically trumps everything else. And then it can be implicit or explicit. So in other words, allow everything except X, or we could say deny everything except X. So where we can be very specific and say only allow application A or application B to run, deny everything else. Or we could also say that allow everything to run except application A or application B. This is sometimes referred to as whitelisting or blacklisting, allow or deny. If they are on the whitelist, it can run. If it's on the blacklist, it can't run. So these are just basically two different ways to grant access to an application. Now we have a few different types of access control list. First, we have the discretionary access control list or a DACL, and that is really the most common type of ACL. It allows for an owner or an object to access the specific or specify permissions for specific users and groups. So the owner is able to determine what users have access and the level of access or permissions. Then we have the System Access Control List or SACL. And this is used for auditing, basically specifying which users or which processes should be audited when specific actions are attempted, like someone's trying to log in or they are trying to access a folder or a file, perhaps read, modify, or even delete. So we can audit for specific activities that then gets written to an event log or a security log, which we can then go back and refer to or monitor for a later review. Or we could have it sent to a system that's monitoring for more real-time activities. And if one of those actions take place, we could become alerted more or less in real time. So a few use cases for access control list, we have file systems. So ACLs are used to control who can read, write, execute files and directories, as we talked about. It can also be used in the context of network security. So ACLs can be used in routers and firewalls or switches to control traffic by specifying which IP address or which ports are allowed or denied. And we also have ACLs in use for database systems. So ACLs define which users can access and modify specific data tables and rows. And then also when it comes to cloud services or web applications, so ACLs are used to manage permissions for users, resources, even API endpoints. The same concept applies when you're talking about ACLs, just different use cases and different contexts. And then everyone's favorite, the concept of least privilege. So this is the practice of providing individuals or systems with the bare minimum level of access for permissions necessary to perform their job function to specific tasks. If you do that, you may not have a happy user, but you're definitely securing your environment. It's also very granular. It can be default deniers, so if I don't explicitly say that you can do something, then it's simply implied that you can't. And then we can also do something called role-based access or RBAC. So upon that role you're assigned, you have certain permissions granted with that. In other words, if you are in finance, you automatically have certain permissions set. But if you get moved from finance to say HR permissions, those permissions are taken away and the new permissions are granted. So that way you only have permissions required for your job, nothing more. Next, let's talk about patch management. So when it comes to patching, we have a few things like firmware is the software that runs chips and pieces of infrastructure. Things like network interface cards or NIC cards, bus adapters, also disk drives, graphics card. And by not updating firmware or by updating firmware out of sync, it can sometimes create compatibility issues when other things are updated and if it's not in sync. So if you update the firmware on something and conflicts with the other components within your machine, you may have to do an upgrade kind of top to bottom to make sure everything stays in sync. On a general PC, typically it's not a problem, but when you have a very large scale pieces of infrastructure, hyper coveraged infrastructure and so forth, we have a lot of pieces to the puzzle. You have to take into consideration how to actually upgrade to make sure that everything is done in lockstep. And then when it comes to operating systems, vulnerabilities are constantly being discovered, as we know, and one of the best defenses is to keep your systems patched and up to date. So if you and when a cyber incident occurs, hopefully it never does to you, but more than likely it will at some point of time. When it does happen, first thing I'm going to say is where your system's patched. So you don't want to be on the receiving end and that is saying like, I haven't patched anything maybe in the last 6 months or something like that. But wait a minute, that CVE came out and that vulnerability was discovered 11 months ago. We haven't patched systems yet? Yeah, that's not a good thing to come back and say no. That's referred to as RGE. I think I mentioned that one before, a resume generating event. You don't want to do that. So keep things patched and updated. And then of course applications. Applications are just like operating systems or firmware or drivers, should be kept in sync as much as possible. You may need to refer to your hardware compatibility matrix, which we talked about in the ACL hardware compatibility list, to make sure that the updating one thing doesn't necessarily conflict with another. But as a general rule of thumb, you want to make sure we keep our firmware and our operating systems, our applications, all of those good things patched and updated as quickly as possible. Okay, next up, let's talk about encryption. We have a few steps to talk about here. So, we have encryption at rest, which is basically data that's sitting on the disk. Whether that's a solid state drive or magnetic, the concept is the same. We're encrypting the data that's at rest, it's sitting on a disk somewhere. Next, in transit, we would encrypt data that is being sent from point A to point B. As it goes on the wire, we would use things like IPsec for VPN or SSL, and we would encrypt that communication so that way it prevents eavesdropping. If someone were to intercept the connection, they would not be able to understand what it says. It would basically just be a grabbled text and then also encryption in the memory or encryption in use. So this is the data where in the memory and that's actually been used by application and it's sitting in your RAM or random access memory. So these are the three different types of encryption that can be used or we should be aware of and consider when we are designing our systems and making sure we are securing our infrastructure. And then these things can be managed by hardware or software. And if it's the software side of things, we are talking about things like BitLocker and VeraCrypt. There are a number of different tools out there that can encrypt your data. It could be at file level, or it could be at the folder level, or at volume level. You can also encrypt an entire disk. And then we also have hardware. We're using things like TPM chips or HSM modules, which allow you to encrypt and manage those things externally. In addition to things like network interface cards, and then we have the IPsec build in or some type of encryption algorithm built into your card itself. But regardless whether it's software or hardware, the concept is the same. We want to encrypt data to avoid interception, eavesdropping, and to keep the data itself secure. Next is configuration management. So this is the practice of ensuring systems and software are there to define standards and configuration standards to standardize the environment. And then that reduces the risk. So the more things are the same, then the less chances we have that someone off or some slow fake that can introduce either risk or something we have to troubleshoot when something goes bump at night. If everything's the same, we know how to fix things very, very quickly. It also adheres with compliance requirements. So depending upon the environment that you work in, the industry that you work in, you may have some very strict compliance requirements. And by standardizing and having configuration standards in place, and keeping them documented for as long as those things adhere with those compliance standards, then it makes your life much easier. It also reduces attack surface. So again, once we understood actually what's in your environment, what applications, what ports, what components actually make up the software, all these different things, we then fully understand what's there. We can turn off what's not needed and reduce our attack surface. And then it assists with documentation and also with change control. The larger the environment gets, the change control becomes harder and harder. So, by fully understanding what's in place, what systems, what applications, and so forth exist, when we do make changes, then we can understand what are the potential impacts of those. What are the downstream impacts, upstream impacts, and so forth. What things depend upon the changes that we make or the applications that we are making changes to. All of these things help to secure environment and reduce risk. So, just a few quick examples of some configuration enforcement tools. For automated management, we have things like Puppet, Chef, and Ansible. For compliance auditing, again, some tools like Qualys and Expose. For patch management, we have WSUS or SCCM. And again, I understand that these aren't necessarily endorsements for any one specific product or another. I'm just giving you some examples of tools within each category which are widely being used. If you want to research them further on your own, perhaps you're already familiar with. For change control, we have things like ServiceNow or Remedy or Jira. Jira can also be used for bug tracking and so forth. For continuous monitoring, we have things like Splunk or New Relic, Sumo Logic, etc. And for policy enforcement, things like Group Policy or JAMF Pro if you are in an Apple environment. So again, not something that you specifically need to know for the Security Plus test, but I just wanted to make sure that you have an understanding of what tools kind of fit into what category so you can dig in a little bit deeper on your own. Okay, next is the interesting one, that is something referred to as SOAR, and then it is usually known as Security Orchestration and Automation Response. So here we have a SOAR platform that is basically a tool set of an application that allows us to orchestrate and automate certain responses to security events that happen within our environment. As an example, we have a couple of different things that we'll feed into a SOAR platform. We could have events occurring in a network. We have SIEM information systems, which is security information event management, or EDR endpoints, which are basically applications installed on your host. And then that is endpoint detection and response, which allows us to become alerted and potentially mitigate things at the actual endpoint or at the host. Now, all of these three things can be fed into your SOAR platform, and that sort of platform then can also integrate or connect or communicate with ticketing systems and different type of controls. So a ticketing system like IT ticketing and change control, and then also various controls like alerting, whitelisting, or third-party tools. In other words, we could have some piece of information, a trigger or an alert come in, whether it's a system or something that picked up from a SIEM solution or an EDR. So one of these things would trigger, it feeds into the SOAR platform. The orchestration and automation then could be potentially create a ticket within our ticketing system and then spin up some activities to take place. Some work that gets assigned to various groups or users. It could kick off various controls like alerting or whitelisting, or some type of third-party tool like PagerDuty is an example, to alert your offshore team to take some action, to check in and make sure everything is up and running, or if it needs to be further investigated and so forth. So these SOAR platforms are very robust and allow us to automate a lot of things that used to be manual process. And then from there, it allows us to kick off some things like playbooks and runbooks. Now, what do I mean by that? A runbook or a playbook? Basically saying what ticket needs to be created or what changes need to be implemented if something gets triggered and we kick off a workflow. It allows us to basically specify what needs to happen, and so in what order. Which team needs to be engaged? What level of management needs to be alerted potentially? Also, what additional resources needs to be called out? Monitoring failover sites, call outs to specific groups, again depending upon the nature of the incident. Also, does it need to be any type of a network change? Does it need any isolation or containment or segmentation? We talked about those briefly. All of those things can be automated if they identify an attack or one part of the network. It could be potentially isolated and cut off access to the rest of the network to stop spreading. It could even spin up clones or snapshots. It could do a failover, perhaps to a dark IP space to allow some things to continue to run, or again to isolate. It could also kick off investigations, start capturing logs, and specify types of data. It could also initiate forensics with the prevention of evidence and chain of custody and all that great stuff. All of these things can be potentially be automated via these platforms. Now let's talk a little more about endpoint detection and response, EDR. So some of the key features are the ability to monitor and collect activity from various endpoints. So what we see is going through the network. We can analyze that data, identify threats, patterns, indicator of compromise. It can automatically respond to and identify threats to remove and mitigate them. Notify appropriate teams. We can kick off forensics and analysis tools to research threats and also search for suspicious activities. So you can see it does a lot of the same things that a source system would do, but in the previous context, the EDR endpoint would actually feed into a larger source system, which is more robust and has the ability to integrate with a lot of other systems as well. Next, we have the host-based firewalls. And the firewalls you might be familiar with is typically that they block traffic based on the port, protocol, and an IP address or an application. So, the host-based firewall, as you might have guessed, protects a single host only, and they are not network based, and this is usually done by restricting applications. And as mentioned previously, applications can also be whitelisted or blacklisted. So host based firewalls again are very host specific. They are not as robust as network based. They only protect that single host on the network. So unless you're in a very small shop or you're doing something very specific for a single application, it's generally a better idea to have larger, more robust firewalls at the perimeter of your network and potentially inside of your network if you're in a highly secure environment, or you want to keep one domain or one section of your network separated from the others. Next, we have something referred to as HIDS or HIPS, HIDS or HIPS, and that stands for Host-Based Intrusion Detection or Host-Based Intrusion Prevention System. It's similar in function to a network intrusion detection system or network intrusion prevention system. Again, we are talking about a host level versus a network level. Now, HIDS systems can detect anomalous behavior and alert as needed. The differentiation being HIPS or intrusion prevention system functions similarly but also can take additional action if necessary. So not just alerting, but it can actually take action. Shut down ports, turn on specific applications, logging, so on and so forth. And then some additional security considerations, disable ports and protocols. We've talked that about briefly, but disabling ports and specific protocol reduces the attack surface and limits the attacker's recon activities. So the less we have exposed on our network, if a bad actor is doing some type of penetration testing or if they are doing some type of recon activity, the less that they can probe and less information they can get back. That is, of course, less information for them to go on, and it reduces the overall attack surface. And then also changing default passwords. Now this sounds like a no-brainer, but it is a frequent attack vector. It is very easy to remediate, but it's often overlooked. That's why we have to make sure that we are very diligent with this, and this is one of those things that comes back to user education, making sure that the users are aware they need to change passwords. You don't allow the default passwords, but if you do a simple Google search, there are tools out there on the internet that will search publicly facing pieces of infrastructure. And it's always amazing to me how many of them are out there in their default state. So please change default passwords immediately. And then removal of unnecessary software. This kind of goes back to disabling ports and protocols. We want to reduce the attack surface as much as possible by reducing open ports, software, and so forth. By removing that software, it's also less us or for us to patch and less for us to update and monitor, because we have talked about it before, that if we install software that we don't monitor it, we don't use it, or if it's installed by default, perhaps bloatware, it's things that we never touch, we don't look at, we don't think about that. Well, we are not going to update those things. We are not going to patch them. So eventually they become out of date. There's vulnerabilities that potentially exist and we are not even paying attention to it. So if you don't need a specific piece of software, remove it from your systems. Okay, so congratulations. So this is just of what we have all studied today. Now with this, that's 2 down and almost halfway there out of the 5 domains in the entire course. 2 down and 3 more to go. Thanks for sticking with me. Again, congratulations for getting this far. Keep up the great work. I'll see you in the next domain, that is domain 3. Feel free to go back and review the video if you need to. And of course, share the video to spread the knowledge.